Welcome back everyone. I'm Dr. Abhinaya Impamani from University of Florida, NFRE Sequencing. In the previous session, we saw how the Arduino automatically switched the LED on and off depending on the soil moisture. But what if the farmer wants to control manually? For example, to stop the irrigation during the rainfall or turn it on before planting new crops. That's what we are going to do today. I welcome you all to this session 4. Make it smart. Decisions with buttons. Today, we will learn how to bring manual control into the smart irrigation system using a push button switch. You will see how a simple button can send a digital input to the Arduino, toggle between dry and irrigating states, and let the farmer override automation when needed. So in order to design the circuit, we would be in need to understand what is a push button and how it works. The push button is a small but a very powerful input device. When you press it, it connects 2 points in a circuit allowing the current to flow, and when you release it, the connection breaks and the current stops, just like the switch on and off. We call this as momentary push button switch because it only works when you press it. In Tinkercad, this component is shown as a small button with 4 legs. As I mentioned, when the push button is pressed here, the circuit between the two sides closes, allowing the electricity to flow through. When connecting the components in a push button, it is very important in order to ensure that the wires are placed on the opposite sides of the switch, like this. You can connect them either diagonally opposite legs or to one pair of legs on the opposite ends, like shown in figure 4. Making proper connections is essential. If the wires were placed on the same side, the circuit won't function correctly. So with this basic knowledge, let's go to Tinkercad. Click sign up, create a personal account, and then try to sign in with Google. Click create circuits. Now it's time to bring the components onto your screen. The first important component is the Arduino. I will pause then and there so that you can do it along with me. The next important component is the breadboard. Next, we would be in need of 2 LEDs, red indicating dry and green indicating irrigation. Next, we would be in need of a resistor for the 2 LEDs. Next, we would require a push button. The ground of the Arduino should be connected to the negative of the breadboard. Try giving a black wire color whenever the ground connections are involved. The cathode of the LED should be grounded. The other end of the cathode for the second LED should be grounded as well. You can change the color of the LEDs for better understanding. The push button is placed across the middle trench of the breadboard. One side of the push button should be connected to the ground. The opposite side, either terminal 2A or terminal 2B. You should not use terminal 1B. We have to use only terminal 2A or terminal 2B. The opposite side connects to the digital pin 3 of the Arduino. Try giving a different color. With this, the push button connections are done. We will activate the Arduino internal pull-up resistor in the code in order to stabilize the button input. We will get a more understanding about it as we code it. Now let's move to the LED. The anode of the LED is connected to the resistor. The other end of the resistor is connected to pin 5. Similarly, now let's start exploring the green LED. The green LED here represents the irrigating mode. So the anode of the green LED is connected to the resistor, and the other end of the resistor we are going to connect to the pin 6. With this, the connections are done. Now, let's go to the coding part. Let's make the circuit come alive using this Arduino code. The code will detect when the button is pressed and switch between the two states, dry and irrigating. Let's see how to do it. Click Code. In code, we have 3 different edit modes available: blocks, flux, text, and text. Click Text and then click Continue. Now it's time to write our code. This inbuilt code will come on your screen. The reason is because you have dragged the Arduino board onto your workspace. That's the reason this C++ code comes onto your screen automatically. You can delete it and paste the code which I have shared with you. Now, it's time to explore the code line by line. Const int red LED equal to 5. What does this mean? This is going to tell the Arduino that red LED is connected to the digital pin 5. We have used const here. The reason is because we make sure that this number never changes while the program is running. Const int green is equal to 6. What does it mean? The green LED is connected to the 6th pin. Const int push button equal to 3. This means that the push button is connected to digital pin 3. Next, bool toggle state equal to false. So we are going to learn about a very interesting variable called bool. We call bool as a Boolean variable. Boolean variable means it has only 2 conditions, like either true or false. This is being created in order to remember the current system state. In simple words, I can tell that this is going to act like a memory switch for us. It remembers whether irrigation is on or off. Next comes the void setup. So this setup function is going to run when the Arduino board is powered on. So it's like getting ready step before the main activity begins. And inside the setup function, we are going to configure the various input and the output pins. Now let's take the first one. Pin mode red LED equal to comma output. So what does it mean? This tells the Arduino that pin 5 will send out signals to control the LED. We know that LED is an output device. So we are indicating the Arduino that I'm going to connect a LED at pin number 5 and that's an output device. Similarly, pin 6 will control the green LED. Pin mode push button input pull up. The button pin is set as an input here. The reason is because only when you push this button, you're going to visualize something in the output. That's the LED, right? So push button is the input device here. So the button pin is set as an input and the Arduino's internal pull-up resistor is activated. This is being done in order to prevent any random fluctuations. So this means that the pin is going to stay high when not pressed and go slow when the button is pressed. Digital write red LED comma high. So initially, I'm going to keep my red LED on, showing that my field is dry. The green LED is off at the starting condition, means the irrigation is off. With this, I have configured my setup loop. Let's go to the void loop. Inside void loop, we are going to configure the read buttons. Void loop is like a function which is going to run continuously. So you can think that this like on Arduino heartbeat, and it keeps repeating these steps forever. Int read button is equal to digital read push button. So what this does is the Arduino is going to read the state of the push button. If the push button is not pressed, the pin reads high. If the push button is pressed, it reads low because of the pull-up setting. Now, we are going to check whether the read button value is equal to 0. This checks whether the button is pressed or not. Next comes a very interesting line. Toggle state is equal to exclamatory toggle state. So this line is going to flip the state. I can give you a shortcut to remember this. It's a shortcut that is going to tell the Arduino change to opposite state from before. Imagine, I need to give a memory to my circuit. The Arduino need to remember whether irrigation is currently on or off. All these are not a one-time reaction. It needs to remember the previous state as well. So, in order to make it as a state-based control, to make the button behave like a toggle switch and just not like a momentary one, and to help to solve our real-world systems, we are going to use this particular line, toggle state is equal to exclamatory toggle state. Without this line, the circuit would not remember what the previous state was. Next, if the toggle state is equal to false, what happens? The irrigation is off, means green LED is low and red LED turns on. Else, digital write red LED is low and green LED is high. So if the toggle state is true, it means irrigation is on, so the green LED turns on instead. I'm going to give a delay of 500 milliseconds so that one press is registered properly. Now, Let's start the simulation. You have mentioned in the code that red LED should be on at the initial phase, and you can witness that in the output. And the green LED will be in the low condition, means off. Once you press this push button, you can see the red LED turns off and green LED turns on. And if you press this button again, it works the opposite. So what's really happening here? The push button acts as a farmer's decision. The Arduino acts as a brain that remembers what state the system is in. That's the beauty of writing that line toggle state equal to exclamatory toggle state. The LED act as an indicators here. Red means dry and green means irrigating. Each time you press the button, the Arduino changes the decision, switching between dry and irrigation mode automatically. This is simple but powerful way to bring the manual control into any smart farming project. We have now learned how the digital inputs like the push buttons allow the systems to respond to the human actions. And I'm so happy to see that all of you have did it along with me. See you all in the next session. Until then, keep exploring, keep experimenting, and as always, happy learning.